Hello, my dear students. Welcome to my channel, Physics by MKR. Today, I am going to explain vector addition rule. Now, let us find the differentiation between vector addition and scalar addition first. First of all, you can add scalar to scalar and vector to vector. You cannot add vector and scalar according to the principle of homogeneity of dimensions. And vectors follow almost all the rules followed by scalars. But additionally, they follow some other rules which scalars do not follow. Let us understand those laws. For example, take triangle law, parallelogram law, and polygon law. These are the additional laws followed by vectors other than scalars. Then what are the common laws followed by vectors and scalars? See, for example, we have three laws here. Commutative law. The meaning of commutative law is the order of addition is not important. That means you can add P with Q or Q with P. You will get the same result. For example, 4 plus 3 is nothing but 3 plus 4, which is equal to 7. Similarly, associative law. P plus Q plus R. Here, Q is associated with P, but here, Q is associated with R, but the result is same. 4 plus 3 plus 2 is same as 4 plus 3 plus 2. And there is another law which is called distributive law. Here, P is distributed among Q and R. That means if you multiply 4 with 3 plus 2 is nothing but 4 multiplied with 3 plus 4 multiplied with 2. These are the laws followed by scalar addition. Whereas in the vector addition also, the similar laws are followed. For example, A bar plus B bar is same as B bar plus A bar. The order of addition is not important. And similarly, A bar plus B bar plus C bar is nothing but A bar plus B bar plus C bar. Here, B bar is associated with A bar and B bar here is associated with the C bar. And regarding distributive law, these are the two vectors A bar and B bar multiplied with a scalar. That means this scalar is distributed among the two vectors A bar and B bar like this, NA bar plus NB bar. So these are the common laws followed by scalars and vectors. Knowledge of vector is essential to understand all branches of physics. So that's why you must have perfect knowledge about vector addition, vector subtraction, dot product of vectors, and cross product of vectors. So first we learn about vector addition. And for convenience sake, I am dividing this process into three methods. First method is geometric method. Second one is numerical method. And third method is component-wise addition method. So let us first discuss about the geometric method. As I told you in the previous class about the geometric representation of a vector. A vector is geometrically represented by a directed line segment. For example, take A bar is between 2 points A and B along a straight line with arrowhead, and B bar is between 2 points C and D, initial and final points, making some angle with A bar. So we have to add these two vectors now. To add these two vectors, you must know the angle between A bar and B bar. Then how do you measure the angle between A bar and B bar? So you have to extend the arrow of A bar so that the angle between the two arrows, arrow of B bar and arrow of A bar, is the actual angle between A bar and B bar. It is not just the angle between two lines. So first of all, you have to identify the angle. There are two angles about these two lines. One is inside theta dash, and there is theta here, and you may mislead for the angle between A bar and B bar. You have to consider the angle between the two arrows. Now, from the principle of invariability of vector, you can move the vector B bar parallel to itself in any direction without any change of vector. In that process, I framed a triangle like this. The initial point of B bar is added with the final point of A bar in one direction, that is in the anti-clockwise direction. A bar and B bar are representing the two adjacent sides of a triangle. Now, their resultant C bar, which is A bar plus B bar, is represented by the third side in the opposite order, that is in the clockwise direction. So this is the triangle of addition theoretically. Understand? Now, how you add these two vectors A bar and B bar numerically? Numerically means we must measure the magnitude of A bar and B bar and also the direction of A bar and B bar by specific equations, so that if you are given some numerical values, you can find the resultant magnitude. And about the direction, we are measuring the angle made by A bar plus B bar with C bar. That is nothing but A bar plus B bar is nothing but C bar. So we have to measure the angle made by C bar with A bar, which is alpha, and also angle made by C bar with B bar, which is beta. So by measuring alpha and beta, you are measuring the direction of the resultant. By measuring the modulus of A bar and B bar, you are measuring the magnitude of the resultant. So let us see the parallelogram of addition. If two vectors A bar and B bar represent the two adjacent sides, here. A bar and B bar represent two adjacent sides of this parallelogram. The adjacent sides are OP and OQ. Then the parallelogram is completed, OPRQ. In parallelogram, as you know, the opposite sides are equal and in the same direction, parallel. So if OP represents A bar, QR also represents A bar. If OQ represents B bar, PR also represents B bar. The magnitude of B bar, that's all. Now, in this parallelogram, the angle QOP is the angle between A bar and B bar, and I am extended this OP up to S by drawing a perpendicular RS, so that I will have a right angle triangle OSR to measure the magnitude of A bar plus B bar. So in this parallelogram, there are two right angle triangles. Observe this. One right angle triangle is SPR. This is SPR. And in this angle SPR is theta, so that RS is opposite side and PS is adjacent side, and their magnitudes are, this is B sin theta and this is B cos theta. And in this big right angle triangle OSR, this OS consists of two parts, OP which is equal to A and PS which is equal to B cos theta. From Pythagoras theorem, this hypotenuse square R square is equal to sum of the squares of the two sides, OS square and RS square. And OR square is nothing but C square. And OS square is nothing but OP plus PS whole square. And by substituting all that, you will get C square is equal to A square plus B square plus 2AB cos theta. And the modulus of A bar plus B bar is equal to modulus C of C bar, which is also equal to C, which is given by root of A square plus B square plus 2AB cos theta, where AB are the magnitudes of A bar and B bar. And similarly about the direction, the angle made by the resultant vector with A bar is alpha. And from this big right angle triangle, this angle is alpha. And tan alpha is opposite side by adjacent side, which is Rs by Os, which is B sin theta by A plus B cos theta. So if you know alpha, you can find beta because theta is the sum of alpha plus beta. You need not have separate equation for beta. Simply by measuring alpha, you can measure the value of beta. That means the direction of the resultant vector is completely described by alpha and beta, and the magnitude is given by this numerical formula a square plus b square plus 2ab cos theta. So, as you know, with the increase of theta, the value of cos theta decreases. That means, as theta increases from 0 to 180 degree, some parallel to anti-parallel, the magnitude of the resultant, that is modulus of A bar plus B bar, decreases from A plus B, the maximum, to A minus B, which is minimum. A plus B to A minus B. And from this, we can also assess, suppose if A is greater than B, naturally, a resultant orients towards the greater vector. That's why this A bar, when A bar is greater than B, B bar, that's modulus of A bar is greater than B bar, then alpha is less than beta. So, if A is equal to B, then this big equation, by substituting A square instead of B square, and also A instead of B, we will get a simplified equation for the modulus of the resultant, which is 2A cos theta by 2. So, when you are going to measure the resultant of two vectors of same magnitude, you can use simplified formula rather than this big formula, which is 2A cos theta by 2. And because these two vectors are of A same magnitude, the resultant lies exactly between A and B. That's why this alpha is equal to beta is equal to theta by 2. So this is about the direction of the resultant of two vectors of same magnitude. And if the vectors are not of same magnitude, you have to use this formula for magnitude and this formula for direction. Okay? So this is about parallelogram law and this is about triangle law.